This is a quick overview of the basic features of the Eagle Eye HMS hazard monitoring system. As we look at the main menu, you will see we have a couple of choices. One of the unique features of NAB Automation's Eagle Eye systems is that multiple monitoring systems can easily operate on the same platform utilizing the same high-performance controller. This example shows our GWS digital bin temperature system on the left and our HMS hazard monitoring system on the right. Let's click on the Eagle Eye HMS button to view this system. This demo is operating on our smaller Eagle Eye LT controller, which, as you can see, is capable of handling up to 12 pieces of equipment, or 144 total monitored points. Our larger system, which utilizes our Eagle Eye HD controller, is capable of handling up to 80 pieces of equipment, or a total of 960 monitored points, all in a single controller. Let's examine the layout on the HMS operator screen. You will see that each individual piece of equipment is listed in its own box for quick and easy identification. You can name each piece of equipment whatever you would like in the system configuration screen. Below the equipment buttons, you can obtain information on alarm history as well as a log of any system overrides. The middle two buttons allow the system to be reset after an alarm or overridden by an authorized user to bypass a particular alarm. This allows an authorized user the ability to manually bypass a single sensor point while keeping that piece of equipment and the system itself operational, should it become necessary and is deemed by that operator to be safe to do so. An override log is kept to ensure proper accountability for any bypassed alarms. At the bottom of the screen is the status guide, which simply tells the operator what the equipment button colors represent. Should a sensor failure occur, it is automatically detected by the system and presented on the screen with this color. When you click on that piece of equipment, it will tell you specifically which sensor is in failure, saving you a great deal of time in trying to locate a potential problem. The remaining status colors can be set to represent a variety of variables, depending on the type of sensors that are being used in the facility. Another unique and innovative feature of the Eagle Eye monitoring system is its ability to collect data from a variety of sensors, such as temperature, speed, oxygen level, salinity, pH, plug switches, and much more. In this particular demonstration, we are utilizing primarily temperature data, so the alert, warning, and critical statuses would relate to operating equipment temperatures. In this case, we are using the critical set point method, whereby the administrator sets a temperature at which the equipment will automatically shut down, preventing a possible hazardous situation from arising. The alert status is the first level of alarm for the operator, indicating in this case an abnormal rise in temperature. Should the temperature continue to rise, a warning indication tells the operator that the situation is worsening and action should be taken to prevent a critical temperature hazard. Finally, if corrective action is not taken and the temperature reaches a critical set point, the equipment color changes to red, and that piece of equipment is automatically shut down by the system to prevent a hazardous situation and/or equipment damage. Let's click on a piece of equipment to see exactly what is happening there. Each piece of equipment may be clicked on to view a detailed breakdown of the data presented by each sensor. This piece of equipment happens to be a belt conveyor, so most of the information presented is temperature-based. Since this is a conveyor, a speed sensor is also providing information, which is displayed in a percentage near the top of the screen. As a convenience, the equipment runtime information is provided as well. Additional preventive maintenance functions of the Eagle Eye HMS are detailed on a separate screen. We now have a hazard alarm. We'll acknowledge the alarm and close the alarm pop-up box. By looking at the status screen, we can immediately see which piece of equipment is in warning status. By clicking on that piece of equipment, we can promptly identify the sensor that is presenting the warning information. For the purposes of this demonstration, I've set the critical set point to 90 degrees to more easily illustrate the alarm functionality. Since the temperature is within 10 degrees of the critical set point, the sensor is in warning state, telling the operator that corrective action should be taken at this location to prevent a critical temperature hazard. As the sensor temperature continues to rise, you will see it reach the critical set point. The color changes to red, and the equipment is automatically shut down. If we go back to the main status screen, you will see that the equipment button has turned to red. Once we have corrected the situation that caused the temperature hazard, we can reset the system by pressing the Reset button. The piece of equipment will only reset if there is no longer a hazard present. In this case, the sensor temperature has dropped to an acceptable level, as we can now see in the detail screen. If the hazard remains and the operator wishes to bypass that particular sensor, then the system may be placed into override by an authorized user, who must log in with a user ID and password. The status of the equipment will then change color to indicate the override. This has been a brief summary of the basic operating characteristics of the Eagle Eye HMS monitoring system. For a more detailed demonstration, including our innovative system configuration screens, preventive maintenance features, and data collection capabilities for a variety of industries, please visit the Contact Us page on our website, www.nabautomation.com, or give us a call at 573-339-1622. Thank you for viewing our Eagle Eye HMS demonstration, and we look forward to speaking with you soon.